our today's main session, Oxford-Waseda in Mathematics. We have the opening speech from Professor Kasahara, Professor Bauntura, Professor Giles, and Professor Shibata. The first speaker is Professor Kasahara. Please.
So good morning and good evening. So I'm Hironori Kasahara, Senior Executive Vice President of Waseda University. And I'm also IEEE Computer Society President 2018. So welcome to the today and the tomorrow's symposium. First of all, I would like to thank University of Oxford Vice Chancellor for Innovation, Professor Chas Bantra, and the Head of Mathematics, Professor Mike Giles, and Mathematical Institute, Professor Gregory Seregiri, with Professor Shibata and Professor Ozawa, organizing this very interesting symposium. First, I would like to introduce Waseda University briefly. Waseda University is located in center of Tokyo and founded 1882 by Prime Minister Mr. Okuma. And we have many important foreign guests. For example, Prime Minister Boris Johnson from England, President Bill Clinton from United States, President Hu Jintao from China, and also industry leaders like Mr. Bill Gates and Jack Ma from Alibaba. And Waseda University have 50,000 students, and we have 8,000 international students from 125 countries. This 8,000 is the largest number in Japanese university. And also every year we have more than 10,000 alumni CEOs in Japan. And our 7 alumni became Prime Minister of Japan, and a lot of industry leaders. Founder of Sony, Mr. Ibuka, graduated from electrical engineering of Waseda University, and founder of Uniqlo, Mr. Yanai, graduated from School of Politics and Economy. And also we have a lot of venture leaders. Founder of Mercari. Mercari is the Japanese first unicorn companies. Founder Mr. Yamada graduated from also School of Politics and Economy. And currently IEEE is the world's largest academic societies. President Toshio Fukuda graduated from mechanical engineering from Waseda University, and myself graduated from electrical engineering. I worked as IEEE Computer Society president, the first president outside the United States in 70 years history of IEEE Computer Society. And also Waseda University President Eiji Tanaka, he served as the president of International Political Science Association. Like University of Oxford Vice Chancellor Professor Louise Richardson, also a member of IPSA. This year, University of Oxford and Waseda University exchanged MOU April 2020. Everything started from last year's November. I was invited by University of Oxford giving a lecture in computer science. At that time, I have a chance to talk with Vice Chancellor Professor Louise Richardson and also Martin College Warden Eileen Tracy. Eileen kindly visited Waseda University this January, like this. And quickly we proceeded university level MOUs in computer science, mathematics, and physics. And today we have a symposium. Waseda University I have a responsibility in innovation, like Professor Bantra, and I'm pushing Waseda open innovation ecosystems. This includes industry, academia, collaboration, and we would like to create value-added product with industry. And industry have some profit. We are asking to reinvest part of profit to Waseda universities. And we would like to make a research and hire more PhD students. Japanese problem is we have just only quite few PhD students because students pay by themselves. So we would like to hire PhD students and write more journal papers, international journal papers and conference paper, and also patents. To increase patent, we are helping application of a patent and also a communication communication with patent reviewers. And researchers can concentrate research, and we are helping to get the international patent easily. And with patent, we are encouraging startup companies. To do so, we are preparing the venture fund and also our management teams. And to increase successful probability, we are now collaborating with accelerators in Silicon Valley. I'll talk about the later. So by pushing this kind of ecosystem, we would like to make Waseda University top university in innovation. And to do so, I changed administration system in Waseda University. This spring, we started research innovation centers, and we integrated research strategy center, TLO, entrepreneurship center, and industry collaboration sections. And I'm leading these research innovation centers as a senior executive vice president. And I named this project as Waseda Innovation Ballet Project. Around with research innovation centers, we would like to make many ventures. But in India, we have a lot of ventures around here already, but not well networked. I would like to network existing ventures and professors and students having a dream of innovation. And maybe a few years, 10 years later, we have a big innovation valley with the ventures. And maybe first floor of Research Innovation Center is a kind of a place to find a new venture seed. And we are collaborating with Silicon Valley to accelerate the ventures. For example, Y Combinators and Waseda University and Sozo Venture Fund in Silicon Valley are collaborating and giving a training for new venture leaders. To implement Waseda Innovation Valley, we started Waseda Open Innovation Forum from 2019 because I became a senior executive vice president from 2018. Soon I started Waseda Open Innovation Forums. So this year, 2020, I planned to have an in-person forum with several thousand of participants, but because of COVID-19, we postponed. So next year, March 9 and 10th, we will organize Waseda Open Innovation Forum online. So with collaboration with Japanese government leaders and industry leaders like NTT, Nippon Telephone and the Telegram chairman and the bank president, and also Silicon Valley companies like Cisco Japan president collaborate with us, and communication companies, Rakuten Mobile, they are pushing 5G and local 5G. Also, Sozo Venture Funder, Kaufman Fellows Funder are helping, and venture leaders, Mercari Funder, Mr. Yamada, collaborating with us. And I'm now planning to organize a mini symposium with computer science of University of Oxford during this event. And after that, just on the mini symposium, I would like to invite Vice Chancellor, Professor Louise Richardson as a keynote speakers. So this spring, Louise said she would check her calendar to participate at WOI. So we are expecting to have her keynote speech. So thank you very much for participating, and I'm looking forward to listening at today's interesting speech. Thank you very much for your kind attention.
Thank you, Professor Kasahara. The next speaker is Professor Bountra. So please.
Ladies and gentlemen, good morning or good evening. Thank you so much for allowing me to say a few opening words, and special thanks to Professor Shibata, Kasahara, and Giles for organizing this remarkable event. I was asked to say a few words about innovation, and what I'll do in the next few minutes is just make a few comments around collaboration, open science, translation and enterprise, and then finally finish off with some comments around people. So I'm sure many of the things I worry about, we are all worrying about. Across the planet, we're facing some significant global challenges: climate change, pollution, clean energy, more food, more clean water, more affordable medicines, etc. Now, the solutions to all of these problems, I believe, lie in the hands of smart students and smart researchers and colleagues like you. All of these problems cannot be sorted by any one individual or any one institution. The answer lies in collaboration and partnership. We have to work across disciplines. We have to work with other institutions. We have to work with industry. We have to work with government, with funders, with regulators. And importantly, we have to work with other countries. Now, a great example that was announced yesterday was sort of DeepMind, a Google company which is now solving structures of novel proteins. This is going to transform early drug discovery. I'm sure many of you have heard about the Oxford University's collaboration with AstraZeneca to develop a vaccine. It's maybe worth just saying a few words about that. I mean, that project essentially started at the beginning of the year, probably January, February. A couple of our senior academics, Adrian Hill and Sarah Gilbert, had created a small company called Vaxitech. And in February, March, they got together with senior representatives of the university. So our Vice Chancellor, Louise Richardson, our Regius Professor of Medicine, John Bell, our head of the medical school, Gavin Screeton. They pulled in the UK government, they pulled in multiple funders, they pulled in the regulators, and they pulled in AstraZeneca. And together they decided they were going to generate a vaccine as quickly as possible. And there's a single goal, a single vision, a single focus. And it is quite staggering to see what they have achieved in the past 8, 9, 10 months, what normally would have taken 8, 9, 10 years. And I think it's amazing if we get everybody together and we have one common goal, we can achieve the impossible. So collaboration, I think, is absolutely key. Let me say a few words about open science. My interests are specifically around trying to develop new medicines for patients, new, more affordable medicines for patients. Now, generating medicines for Alzheimer's or depression or schizophrenia or cancer or rare diseases, it's very difficult, it's very expensive, it's very risky, and it's very slow. So what we've been doing in Oxford is we've been working closely with 10 large pharmaceutical companies. We've been working with 7 patient organizations or disease foundations, And we've been working with more than 200 academic labs all over the world. And we've been pooling our resources and our expertise to try and accelerate this. What we specifically have done is we've decided to work on completely novel genes or proteins. And for those, we've generated novel tools, which are high quality. And the reason they're high quality is because we've been working with these 10 large pharmaceutical companies. And we've been doing this to try and drive innovation. And importantly, what's probably unique about our effort is that all of these tools we've made freely available to the biomedical community. We've given them away to academics, to biotechs, and to pharma companies. And the reason we've done that is because I think that's the best thing I can do to accelerate science and therefore accelerate drug discovery. We've also been releasing all of our data and knowledge and reagents to the community immediately. So we don't sit on stuff for 12 months while we're writing up our publication. We release it immediately to try and reduce duplication and wastage. This open science effort has accelerated academic science. It's enabled proprietary projects in industry. It's catalyzed the creation of lots of new companies and lots of jobs by venture capitalists. And hopefully this will deliver more medicines for patients in the future. Let me now say a few words about sort of translation. So taking our research from the lab or the laptop to create impact, so benefit for patients or society or for industry or for economy. We can do that by creating new enterprises. Now in Oxford 5 years ago, we as a university were probably creating 4 or 5 companies a year. And then 5 years ago, we established this translation fund called the Oxford Science Innovation Fund, which was about £610 million. And now we're creating maybe 20 to 25 companies a year to translate our science. What we're also doing in the future and now is we're training more entrepreneurs. Many of our students want to be entrepreneurs. We're trying to attract more entrepreneurs who have experience of scaling up companies. So we don't just want to create companies, we want them to grow into 1 billion, into 10 billion, into 50 billion companies, because that's when they really have impact for society and for the economy, etc. We're also trying to attract more investors to Oxford. We're trying to attract more global industry to Oxford, and we're building lots more innovation space. So hopefully we'll see more progress in this area in the future. And finally, just a few comments around people. And of course, this is the most important ingredient. You know, for us to create solutions to some of the problems I mentioned at the start, we need great students, we need great researchers, we need great leaders, we need great innovators, and we need great entrepreneurs. Now, fortunately in Oxford, we have lots of those individuals. We have some amazing faculty and some amazing young researchers, etc. I should say, I keep talking about researchers and leaders and innovators and entrepreneurs. I do not believe that all researchers are great leaders. I also do not believe that all researchers are great innovators. And I also do not believe that all researchers are great entrepreneurs. You know, if I think of people like Gates or Bezos or Musk or Steve Jobs or Zuckerberg, etc. I mean, these individuals, they have literally changed the world. They have created new industries. They've created companies that are worth $1 trillion or more. They've created hundreds of thousands of jobs. They've created many millionaires and probably a few billionaires. But importantly, all of these companies that they've created are largely technology data companies that they've created in the past couple of decades. Now, I absolutely believe that people like yourself, great mathematicians, great statisticians, great computational scientists, engineers, physicists, material scientists, it is people like you who are going to transform healthcare in the next decade. I believe in the next decade, somebody will create $1 trillion healthcare data company. And I hope maybe working with people like yourself in Waseda University and in Oxford, maybe we can do that together. So thank you for allowing me to sort of present, and I wish you well with the symposium, and this is a fantastic collaboration, and I hope it just continues to grow and grow and grow. So thank you very much.
Thank you, Professor Bountra. The next speaker is Professor Giles. So please.
Hello, as the head of the Mathematical Institute here in Oxford, it is my very great pleasure to speak to you and offer a warm welcome to everyone in Waseda University and elsewhere in Japan, as well as those here in Oxford and elsewhere in the UK, and attending this inaugural Oxford-Waseda workshop. The subject of fluid dynamics is particularly close to my own past research interests. I am an applied and computational mathematician. In fact, my PhD is in aeronautical engineering. So picking up on what Professor Kasahara said, I believe very much in the interaction between university and industry, in addition to the importance of fundamental research, such as the well-posedness and properties of solutions to the Navier-Stokes equations. So for 25 years, I worked very closely with Rolls-Royce, the company which manufactures aircraft engines, helping them to develop CFD, computational fluid dynamics software, to solve the compressible Navier-Stokes equations, to model the flow of air through their engines, and help them to find ways in which to improve their designs. I should also say that international collaborations are an important part of academic research. And in fact, many years ago, when I was still a faculty member at MIT, I visited Japan to go to meetings at companies such as Mitsubishi and IHI to discuss my CFD research. My more recent trips to Japan have been based around my new research interests in computational finance and the development of numerical methods for stochastic computations. And again, my research involves a collaborator, in this case at the University of Tokyo. So international collaborations are very important in mathematics, and I am delighted that we have started this new collaboration between ourselves and Waseda University. And I hope you all have a very interesting workshop with many stimulating discussions, and that this is the first workshop of many in the future. Hopefully, we can all meet in person in the future once this pandemic is over. But perhaps also virtual meetings like this may remain common in the future for environmental reasons, to avoid the requirement for long distance air travel. That is something being actively discussed at present within our university as part of green measures addressing the environmental crisis, which will continue long after the current pandemic is over. Anyway, welcome again, and I wish you the very best for the workshop. Thank you.
Thank you, Professor Giles. The last speaker is Professor Shibata. So please.
Hello, my name is Shibata. First of all, thank you very much. It's a very nice opening speech from Professor Kasahara, Professor Bountra, and also Giles. I am an organizer of this workshop on mathematical fluid dynamics. And Professor Gardi, University of Pittsburgh, and Professor Sryogin, University of Oxford, are scientific committee members of this workshop. They are worldwide leaders of mathematical fluid dynamics, and also my dear friends. So Professor Selyogin kindly introduced me an analysis group of University of Oxford, and then I can organize the Waseda Oxford meeting in mathematics, which is an important part of this workshop. The Waseda Oxford collaboration started, as Professor Kasahara explained, I guess that it started in this spring, and Professor Kasahara kindly asked me that math department join this collaboration. This is a reason why I planned Waseda Oxford meeting in mathematics. I hope this meeting devotes to starting point of Waseda Oxford collaboration, especially in mathematics. I would like to explain a little bit this workshop. The main subject is mathematical fluid dynamics. The Navier-Stokes equation is a fundamental equation to describe the fluid motion, which was first solved by Professor Rayleigh in the whole space, and afterwards by Professor Hopf in general domain. They constructed so-called Rayleigh-Hopf solution after them. The challenging problem is to prove the uniqueness of Rayleigh-Hopf solutions. On the other hand, the study of the existence of unique solutions started later and has continued to expand with the development of several analysis tools. Nowadays, the arrival point is existence of weak solutions with non-uniqueness and their regularities, and the unique existence of strong solutions local in time for any initial data or global in time for small initial data. This workshop contributes any development of mathematical study of fluid dynamics. Next. Finally, I would like to tell you a short history of this workshop. This workshop started 2009, supported by JSPS Japanese-German graduate externship. This support continued up to 2018. This support gives an international training group between Japan and Germany about mathematical fluid dynamics, and the Germany part is supported by DFK. And also, this workshop was supported by Japan Science and Technology Agency's CREST program from 2009 through 2015. In this program, I especially worked on cavitation problems together with Professor Yamamoto and Professor Yoshimura. Professor Yamamoto is already retired and he's emeritus of our university. And Professor Yoshimura is one of the main speakers. Maybe he will give tomorrow. He will give a talk tomorrow. We had a team of mathematical fluid mechanics, computational fluid mechanics, and experimental fluid mechanics to solve a cavitation problem. The cavitation problem, as you know, that one of the main reasons the breaking water machine, like screw of ships, but also good use of the cavitation is, for example, clean up the dirty lakes. So this is a very important problem to solve, and one of the main problems for the engineering people. And the two make group, already Professor Bunker also say that the two make the group of such important problem is very important to make for innovation, I think. And I was a little bit successful for this point. This workshop was also supported by JSPS grant in aid for scientific research S from 2012 through 2016 and A from 2017 to the present. I and my collaborators studied mainly free boundary problems with the Navier-Stokes equations, and I established a systematic method to study the non-homogeneous initial boundary value problems for system. of parabolic equations based on R-bounded solution operators. So this workshop is also supported by Mathematics and Physics unit of top global university project, Waseda University, since 2014. One of the purpose of the top global university project is to give international and interdisciplinary mathematical training to the doctor course student. I'm very happy to hear Professor Giles. He also the computational fluid mechanical. So maybe in the future, we want to make some of the teams to solve some very important problems in the fluid mechanics. So in this, anyway, in this context, I held this international workshop concerning mathematical fluid dynamics this year as well. So thank you very much for your attention.